Hello student, let us start with the next chapter about syllabus, that is nothing but a wave optics. In this wave optics we are going to start. So what exactly we have to do in wave optics that we have to learn. So in the introduction part of the same chapter, what they have done, they are just try to explain the revision of the part that already we have learned in 11th or up to 10th standard. So what type of revision they have taken? In this case, they have mentioned the Snell's law. If you remember, the incident light ray, reflected light ray and the normal, all of them lies in the same plane. Apart from that, the ratio of sine of angle of incident to sine of angle of reflection is always constant. That is nothing but refractive index, and this parameter they have mentioned and revised it for a little bit in this part. Next one is nothing but nature of the liquid. In this nature of the liquid, what they have tried to explain, nature of the liquid, not liquid, nature of the light. So what exactly light consists of? That is nothing. What is the nature of light? How the light get invented? How it consists of? That they try to explain under this topic, nature of light. In which the first part is corpuscular theory. This corpuscular theory or corpuscular nature is nothing but one of the theory given by the Newton, who has invented this theory first time. First time it was invented by Descartes, and then it was developed and modified by Newton. And according to that, they say that the light consists of small and tiny particles, and they have different sizes, and that's one such type of small tiny particle is called as corpuscles. And they have given just details of this, but in this year this part, especially corpuscular nature part, was omitted from the syllabus, so we don't waste much more time on this. Let's go to next, the wave nature. So what exactly the wave nature? Because the corpuscular nature was studied by Descartes and developed further by the Newton, but it has some drawbacks. That theory of corpuscular nature says that the velocity of light in denser medium is greater than that of the rarer medium. Denser means whose density is more, rarer means whose density is less. So the velocity of light in denser medium is greater than that of rarer medium. This is the conclusion of this corpuscular nature, but that was modified later. It is seen that experimental verification says that that was exactly wrong, so that theory was discarded and a new theory was created that comes under this, the wave nature. So wave nature, light consists of wave. That the name. What is the meaning of this wave nature? Nature of light is a wave nature. It is not particle, it consists of wave. So light consists of wave, that is nothing but a wave nature. First time discussed by scientist Huygens, the physicist, Dutch physicist, that whose name is Hygiene, who developed this theory, and sometimes it is said to be wave theory of light, and that is nothing but a wave nature. Light consists of wave. That was explained by the Hygiene in this theory. Now here, to assume that he says that light can travel through the medium as well as vacuum also. But if light consists of the wave particle or wave nature, light has a wave nature, how it will travel in a vacuum? That is a big question at that time. So Hygiene assumed that there must be some hypothetical medium that is said to be ether. Now remember, ether is not substance, as we have, might be all of you have learned this ether in chemistry as a substance, but in this case it is not a substance, it is a hypothetical medium necessary for propagation of light in terms of wave through the vacuum, and that medium is said to be ether. So what he says, Hygiene assumed that there must be such type of hypothetical medium that is said to be ether that must exist in the vacuum, so that light can propagate through the vacuum also. So later on the development goes on ahead, and finally there are some scientists, Hertz, they try to explain this ether. Apart from this, Michelson and Morley performed lot of experiments, and finally they found that such type of hypothetical medium does not exist in the vacuum. Okay, so that was again the drawback of this Hygiene's wave theory, or we can say that wave nature assumed by the Hygiene. Now here, the branch of optics which uses a wave nature of light can be explained by optical phenomenon, and that is said to be wave optics. And as we know, the name of the chapter is also the wave optics. So under this topic we have to learn about the wave optics. Now here, if we just I have told you, in corpuscular theory they assume that velocity of light is more in denser medium and less in rarer medium. But this wave theory, or in this wave nature, Hygiene says that No, that was wrong assumption. In this theory, they assume that velocity of light in rarer medium is greater than the velocity of light in denser medium. There are a lot of phenomena. The new phenomena developed at that time, that are the interference phenomenon, diffraction, and the polarization phenomenon invented, and that phenomenon can be explained well by assuming light consists of wave. So that this is one of the well-known theory at that time on the wave nature. Light must consist of wave, and that was accepted further with little bit modification. On this wave theory, how the light will behave, that we have to learn under this chapter. So let's go to next one. Next chapter, next point of this chapter is what? That is nothing but a dual nature of matter, dual nature of light, dual nature of light. Now see, just initially we have seen light consists of particle called as corpuscles. Then we say that light consists of wave, and finally we come to next topic as dual nature. Dual nature means what? After invention of some phenomena, interference, diffraction, and polarization, this phenomenon can be well explained by assuming light consists of wave. Apart from this, there are some phenomena just like a Doppler effect, Compton effect. The Doppler effect, Compton effect. Apart from this photoelectric effect, these are nothing but the effect, or these are the phenomenon which can be explained by assuming light consists of particles. So from these two different phenomena, two different waves, there is a little bit confusion. What exactly light is? Whether light is a wave or light is a particle. So that conclusion was stopped by assuming this dual nature. Light has a dual nature. Sometimes light behave as a particle. At the other instant of time, it behave as a wave. And that's the reason why the polarization, diffraction, and interference was explained by assuming light as a wave, and why quantum effect, a photoelectric effect, was explained on the basis of light as a particle, because light has a dual nature. Sometimes it behaves as a particle to give some phenomenon related to particle, just like Compton effect, photoelectric effect. Sometimes same light wave behaves as a wave to explain the polarization, interference, and diffraction of light. So this light has a dual nature, and in detail of this dual nature we learn in chapter 14. So there we have to learn this detail, how the light consists of the particle as well as the wave, that we will see in that topic. Now let's go to next, light as a wave. So what should we do? The next topic is what? Light as a wave. So this is nothing but what? The phenomenon light as wave. So light as a wave means what? Light consists of wave nature. It has a wave nature. Now see, we know that light is nothing but what? Electromagnetic waves. Light is nothing but electromagnetic waves. They are transverse in nature. They can travel to the medium, they can travel to the vacuum also. So that is nothing but the properties of light we know. But here, apart from this, light consists of variable two factors, much more. What they are the two factors in electromagnetic wave? Electric and magnetic field together they are. In the light, it consists of and it has a transverse nature. It has two components always, that are the electric field vector component and magnetic field vector component. Both of them are perpendicular to each other, and they are perpendicular to direction of propagation in which the wave is moving, electromagnetic wave is moving, or light is moving. So that is the nature of this. The speed of light in material medium depend on refractive index of medium. The speed of light through any medium depend on any medium. Transparent, obviously it is transparent, because light can travel to the transparent medium only. To the opaque medium, light can't travel. So it depends on refractive index. What exactly refractive index is? Equal to ratio of speed of light in a vacuum to speed of light in that medium. Their ratio is always constant, and that constant is said to be refractive index of that medium. Refractive index of vacuum is 1, and that air is also approximated as 1. Now if you remember, in 11th standard we have learned electromagnetic spectrum. How many type of electromagnetic waves that were distributed according to their frequency and wavelength, group by group, and then that's said to be electromagnetic spectrum. Now, electromagnetic wave has a wavelength whose range is very small to very large. Small means how much small? Its range of electromagnetic waves is up to some femtometer. Less than femtometer, 10 raised to minus 15 meter. This is in femtometer, smaller wavelength, and larger wavelength is up to some several kilometer. Up to several kilometer. This is the wavelength of this electromagnetic wave, or we can say light wave. Has a wavelength femtometer to kilometer, and within this, what they have? They have the electromagnetic waves of different types. Just we have learned in electromagnetic spectrum. There are gamma rays, X-rays, ultraviolet rays, visible rays, infrared, microwave, radio waves, power waves. These are different type of waves whose wavelength is in between this region. Okay, few femtometer, less than femtometer to few kilometers. So here, apart from this, the point to be remembered is that in visible region of spectrum, electromagnetic wave, in visible region, here we are able to identify the colors that waves are visible to human being. So we can identify them in terms of color. And visible light wave has a wavelength from 400 to 700 nanometer. This is the wavelength range for visible light. Visible light, whenever we see the visible light of different color, they have the wavelength in between this. But apart from this, one of the most important parameter to remember is that refractive index of medium depend on wavelength use. Refractive index of any medium, it depends on the wavelength use. If you change the wavelength, if you change the color of incident light, visible light, incident light, change the color, means we are changing the wavelength. If angle of incidence is constant, still we get different result for different color, because we have changed the wavelength. That is a part to remember, except for normal incidence. And white light consists of this all wavelength. White light consists of all 400 to 700 nanometer wavelength, means it consists of all colors together. This is the reason why formation of spectrum and rainbow get obtained. When white light incident on some edge of some prism, it gets separated into 7 different colors. 7 different colors means what? There is splitting of white light into 7 colors, means 7 wavelength gets separated. That is the meaning of this. Now let's go to next. Hygiene theory we have to learn. So these are the basic part about the light as a wave, and dual nature it has. Now let's go to Huygens theory. So what exactly Huygens theory is, that we have to learn. So in this case, Huygens theory, before going into detail of this Huygens theory, first of all, let's see what is the primary and secondary sources of light. So let's start with the primary and secondary sources of light. Sources of light. So what exactly primary sources of light and secondary sources of light, that we have to learn first. So let's see. So primary sources of light are the sources from which the exactly light get emitted from their own. And again, there are 3 different type in primary sources. Let's start with primary sources emit light of their own. They have their own light, they will emit their own light. And there are 3 type of this. Let's start with the first, the high temperature planets, or we can say stars, high temperature stars, planets, they can emit, not the planet, high temperature stars and some different planet also, just like a sun. They have very high temperature. Due to high temperature, they can emit a light. That is the first type of primary source. So one of the best example for this, the sun. Sun can emit its own temperature, because its temperature is very high. It can emit its own light waves, and that light is said to be primary light waves. Again, the light coming from the planets, not planets, stars. Some stars, they are blinking. Blinking means what? They are emitting light. So they are again the primary source of light. And apart from this, there are some objects which get heated to high temperature, just like a tungsten wire, tungsten filament used in bulb. When you switch on the bulb, the tungsten filament get heated, it becomes red hot. When it becomes red hot, it will emit the light. That's again one of the best example for primary sources, which comes under this, because of high temperature they will emit the light. Second part, effect of current passing through that particular thing, so that it will emit a light. And one of the best example we know, tube light or bulb, in which the current get passed, filament get heated, or some effect get occurred, and it will emit a light. So that is the second type of primary sources. Primary sources are emitting light due to high temperature, due to passing a current, and third, due to chemical or nuclear reactions. Some chemical reaction get occurred or nuclear reaction get occurred, and due to that some light get emitted. Okay, and one of the best example is that explosive or firecrackers. Just in Diwali, might be all of you are play with the firecrackers. When we blow the fire, cracker gets split and it will produce what? Fires. It will produce a fire, means what? Firecrackers are one of the best example for this. In these firecrackers, they will emit what? They will emit a light. So that is again another example of this chemical, or we can say nuclear reaction or nuclear energy generator, also it will emit a light. Secondary sources, let's go to secondary sources. These are the primary sources that we have learned up till now. 3 types: due to high temperature, due to passing of current, and due to chemical or thermonuclear reactions. So these are 3 types of primary sources from which light can emit it. Let's go to secondary sources. Secondary sources are the sources which they doesn't have their own light. They can just absorb the light or just some light get incident on their surface, it get reflected back and we feel that it is a source of light. But actually that is not a source of light, it is simple reflector. One of the best example for reflector is a moon. We know moon is not self-luminous. Moon get just when moon we will observe in the night, actually moon is not emitting light, it is reflecting the light. Light from the sun incident on the moon and moon reflect that light, and that is nothing but what? Secondary source. Moon is not actual source of light, it behave as a reflector, and reflector means what? It behave as a secondary source of light. So these are all such type of planets which will reflect the light, they are said to be secondary sources of light. Moon and the planet, objects like human animals, plants, these are the nothing but a secondary source. Suppose we are standing here and some light incident on my body, due to that light the light get reflected from my body and you see me, that is nothing but what? Secondary source of light. So I hope that you get an idea about primary source of light and secondary source of light. Now let's go further to the next topic of the syllabus. What exactly that topic is? Wavefront. Let's start with the wavefront. So it is wavefront. All this topic comes in this Huygens wave theory. What exactly wavefront is? See, might be all of you are learning 8 to 10 standard, 8 to 9 standard, might be 7 standard, the definition of circle. Locus of all point which are at equal distance from the center, the locus means group of all that point, that is nothing but circumference of a circle. Similarly, wavefront are nothing but what? When suppose there is some source of light, so let us assume that in your book they have taken another example, we'll go according to book. Suppose we have the surface, I have just drawn the surface as like this, it is a bucket. Just bucket is kept like this. I have taken a picture from the top, so it is a top surface, top picture I have taken. In this bucket, so top view of the bucket, suppose this is water. This is water kept on this. Now what we have done? We have taken a one stone, small stone we have taken. When we drop that stone exactly at the center of this bucket, here I have dropped that stone. Exactly at the center, here I have dropped that stone. From certain height I have dropped the stone. What will you observe? You will observe that some circular wave get created around this and that wave get traveled to the edges of bucket. Is that? Yes, this is the thing. When we drop a stone at this, circular waves are created and that circular waves are traveling to the edges of the bucket. Is that clear? So in this case, when we drop the stone, first circle comes here. All these waves on all these point on the first circle, their distance from this point where we have dropped the stone, their distance from this point where we have dropped the stone is equal. This is suppose some r, this must be r, this must be r, this must be r. Then this locus means all this point if we join together it will form a circumference of a circle whose radius is r, and this is the first part. Okay, after some time it becomes bigger. Here second circle if you consider, if you connect all these particles together, it will form a second circumference whose radius get increased. Third, fourth and so on. Every time radius get increased. But suppose if you consider the first circle, all the distance are r. Second r1, third r2, fourth r3, so on. So in all cases, all the points are connected by circumference whose distance from the center is constant. So this is one of the example I have told you. Now let's start with the actual example. Instead of water now, suppose we have the source of the light. Suppose I have the light bulb here somewhere. So suppose this is source of light. It is emitting a light in all possible direction. Source of light emitting light in all possible direction. So suppose I have drawn one imaginary circle with this source of light as an origin. So suppose I have drawn this circle with this imaginary light as a origin we have to draw. So let us draw it like this. So this circumference I have drawn with this light as a center of this. In this situation, all the light ray emitted by this light in all possible direction reach to this surface simultaneously. At the same time, to all direction it will reach to this, say, this sphere actually. It is not circle, it is sphere, spherical shape. At the center of the sphere we have kept the bulb, glow the bulb, all light will reach to this surface of the sphere at the same time, simultaneously. We can say they are in same phase. All light ray comings are in same phase. Now we know the formula for velocity of light. What is the velocity? Velocity is nothing but a distance divided by time. From this find out the distance. What is the distance equal to? Distance equal to velocity into time. Suppose the velocity is v, time is t. then distance equal to velocity into time. Now let's see, if we draw this line, how much is distance? Velocity into time. How much this distance? Velocity into time. All these distances are equal to velocity into time, means all these we have reached to the circumference at a time simultaneously. Okay, then this surface, this all point combined together by one surface, and that surface is act as a wavefront at a time capital T here. Is that clear? If we draw further bigger circle, all light ray will reach to this all points, but this distance, here it is Vt, here it may be Vt1, here again it is Vt1, again here it is Vt1. Then what is the second? This is second part, this is the first. First is nothing but a wavefront at a time capital T. Second is what? Wavefront at a time T1. At a time T1, the wavefront, second wavefront get formed, and so on. In this fashion, you can just determine the wavefront. In short, wavefronts are nothing but what? Locus of all point having same phase at a given instant of time is called as a wavefront. So all these are, this is a wavefront at time T, wavefront at time T1. Further you can write T2, T3 and so on. In this fashion you can find out wavefront at different time instant. So wavefront means what? All the point at where light wave will reach at the same time simultaneously, and all light waves are in same phase. All that group of point form is said to be, all that point get joined together, that is said the locus, that is said to be the wavefront. Now the next topic is what? How many types of the wavefront? Basically there are three types of wavefront. First is said to be spherical wavefront. Spherical wavefront. Spherical wavefront. Now what exactly spherical wavefront is? Whatever the example we have taken, bulb kept at the center of the sphere and spherical wave get emitted. So it is, instead of circle, it is what? Spherical surface. Inner sphere 1, let's be outer sphere 2, then more sphere 3. All that are the spherical surfaces, and that wavefronts are said to be spherical wavefront. Light kept at the center of sphere, small sphere, then the bigger sphere, then the bigger sphere, then the bigger sphere. All them are said to be spherical wavefront because they have the shape of sphere. Second is said to be spherical wavefront. Second is said to be cylindrical. Cylindrical wavefront. So if the sources of light are just like just line sources, just like a tube light. Suppose this tube light, it is emitting light in terms of linear source. It will emit light in all direction. Then in that case, you can find out the locus is in the form of cylinder. So this is the locus. At some instant, this would be the locus. So it is cylindrical wavefront. So again, we can draw the bigger cylinder. At another instant of time, this bigger cylinder means it is cylindrical wavefront. That are said to be cylindrical wavefront. Apart from this, if you take a small part of this cylindrical wavefront, this small part if you are taken, and if you just modify it, I have just magnified it is a vertical straight line, linear it is, and that is said to be third type of this, that is said to be plane wavefront. So basically there are three type of wavefront according to shape of wavefront: the spherical wavefront, cylindrical wavefront, and the plane wavefront. Apart from this, let's again one more point is remaining. Suppose this is sphere, it is not circle, it is sphere. At the center we have kept the source of light. So this is nothing but what? In this case, this is said to be wavefront. At some time instant, it is said to be wavefront. Apart from this, I have taken a small portion. This portion I have taken it here somewhere. So it becomes like this. It is what? Magnified view. I have drawn this magnified view. I have just zoomed this part. You get here straight line. Straight line means what is linear source. So from spherical as well as cylindrical wavefront, the small part of spherical or cylindrical wavefront, if you take, it comes in the form of plane wavefront. Just like one of the best example they have mentioned. We know that when we are walking on the earth's surface or standing on the earth's surface, we feel that earth's surface is flat surface. But actually we know earth is curved. Because dimensions of earth are very large, so we assume that it's a flat surface. Similarly, dimensions are very large, the small part act as a plane and flat surface, and that wavefront is said to be plane wavefront. So there are these three types of wavefront: spherical, cylindrical, and plane wavefront. Apart from this, the next topic of the syllabus is what? Hygiene principle we have to learn. Let's go to the hygiene principle. So let's start with this. What exactly hygiene principle is? Hygiene's principle. So Hygiene Principle says that whenever, just we'll read the statement first, then we'll go in detail. So let's see each point on the source. Sorry, let's start with the again. Let's see the statement directly. Hygiene's principle statement. Each point on the wavefront act as a secondary source of light. It will emit a secondary waves called as a wavelet in all direction. Wavelets in all direction which travel with the speed of light in the medium. The new wavefront can be obtained by taking an envelope of this secondary wavelet, traveling in forward direction, and is thus envelope of secondary wavelet in forward direction. The wavelet traveling in backward directions are ineffective. This is most important parameter to remember, as here they have just assumed that suppose there is some sources of light, it will emit a waves in all possible direction. It will form some wavefront. That wavefront act as a secondary wavefront. See, we know that suppose there is one source. Suppose this is source of light. It is emitting light in all possible direction. Here it is surface where all the wave come simultaneously here, here and here. This distance is same. It is suppose V into T, V into T, V into T. Locus of all this point is said to be wavefront. Suppose it is a wavefront. We get here wavefront. It is definitely spherical wavefront because it is spherical bulb we have taken. So this is spherical wavefront. Then according to this Huygens principle, he says that every point on this spherical wavefront act as a secondary source of light. So this is act as a first source. Now we consider three sources: two source, third source, fourth source, and five source. They act as secondary source of light and they are emitting their own secondary waves in all possible direction. So they are emitting the waves like this. So these emitted waves are nothing but what? Secondary waves emitted by points on the wavefront. They are said to be wavelets. And now if we draw the line to this tangent to all the secondary wavelets at all the points, then suppose this initial is P and this is Q. The final is P dash Q dash after time T equal to T. Then what we get? See, according to Hygiene principle, this is source emit a light. You will get a PQ as a wavefront. According to Hygiene principle, PQ acts as a secondary source of light. It will emit a secondary waves or wavelet in all possible direction. So it has this dotted dots I have given. These are nothing but a point on this wavefront, and they act as secondary source. They will emit light like this. I have drawn this. So heavy sphere. They are nothing but a light emitted by these points on the wavefront. Now if you draw tangent to this all wavefront, light emitted by the secondary wavelets, this P dash Q dash we get. And what is this P dash Q dash? It is again another wavefront that we get here at a time T equal to T1, suppose greater than T. Another time instant we get tangent to all this wavefront, we get a new wavefront. These are the statement of this Huygens principle. Another statement is remaining: the wave moving in backward directions are ineffective. We have considered the wave is moving in forward direction, in this direction only. It comes in backward also like this. It must comes in backward because they emit light wave in all possible direction. But this backward light emitted are ineffective. You should not consider a backward. You should consider only forward. Further, you can consider here some point. They act as secondary source of light and they will emit the secondary waves. So we get again the wave like this. So such type of, again you draw here tangent, again we get P double dash Q double dash as a another wavefront at another time instant T1, that is at T2. So this is nothing but a application of this Huygens principle. So I have tried to explain you here by using this diagram, that is for spherical wavefront I have tried to explain. But in your book, if you see, in your book there is one figure 7.2b, that is nothing but this, that I try to explain here like this. In your book they have just drawn it like this, horizontal, I have taken vertical. That is the difference. And that is the 7.2a. The process of that is nothing but the progress of plane wavefront in terms of plane wavefront. This is what? Spherical. In case of plane wavefront, what would be that? That you should consider the plane wavefront and just according to Hygiene principle apply the same thing. Suppose this is a plane wavefront. Okay, plane wavefront we are getting. Consider all the point on this plane wavefront that behave as what? Secondary source of light. They will emit a secondary waves in all possible direction. So they will emit a secondary waves in all possible direction like this. Suppose I have drawn it. So it is drawn here. It should be at the center. So it should be at the center. So let us consider the center. So these are the secondary waves we are getting. Now if we draw tangent to them, it becomes, suppose if you draw a tangent to all of them, it is again vertical line. Again it should be P and Q. So this initial should be P and Q, final should be P dash Q dash, is nothing but a new plane wavefront at a time t equal to t1. This is at t equal to t, suppose. Is that clear? Again, the backward direction, the waves are ineffective, so we have not correct. Just we have not considered that, we have eliminated that. Same thing. This is the propagation or progress of plane wavefront, and spherical wavefront according to Hygiene principle. So this is nothing but a propagation, or we can say construction of spherical wavefront that I have told you initially, and construction of plane wavefront that I have told you now according to Hygiene principle. Lot of time in examination they have asked this: explain the construction of plane wavefront or explain the construction of spherical wavefront on the basis of Hygiene's principle. This topic is lot of time they have asked, so you should prepare it well. Okay. Now next one. Okay, I have already done it here. Next one is nothing but reflection of light at a plane surface. On the basis of this wave theory of light, how the wave gets reflected on the plane surface. Reflection of wave on the plane surface on the basis of the wave theory of light. That point is remaining. I think it is better to stop now. We'll see that point in the next topic or next video. We'll start with that. Okay, so just watch my video. After watching, try to read the same topic in your book. Still, if you have any query, you are feel free to ask me. I hope that you understand it very well. So just prepare yourself well, and just next period we start with the reflection of light at a plane surface. Again, next topic is what? Reflection of light at plane surface, then refraction of light at boundary of the plane surface between two media, and that topic is eliminated this year. So we are going to skip that topic. Just we will see reflection of light at plane surface. Then the next one, polarization, that also removed from your syllabus this year. Directly we jump to the interference then. Okay, I hope you are safe and just studying very well. Those who have not started their study, please start it now, because definitely exams are going to head. Thank you very much. Be careful.